lecture we are going to learn about regenerative cycle. In previous lecture we have learned about reheat cycle. As we know that efficiency is equal to output by input. I have mentioned that efficiency could be increased either by increasing the output or by decreasing the input. In reheat cycle, efficiency is increased by increasing the output, and in regenerative cycle, efficiency is increased by decreasing the input. This is done by, just see, this is the heat supplied. If this heat supplied is low, automatically the efficiency will be low, because efficiency is equal to net work done by heat supplied. So we have to minimize the heat supply, and this heat supply is going to be low if the water that is being pumped by pump 2 have certain amount of heat content. Then only we need to supply very less amount of heat to the boiler. Then only our efficiency will be increased due to decrease in the input. Now, let us understand this flow cycle of the regenerative cycle. First, heat is supplied at a constant pressure to the boiler. Now, the steam that comes out of the boiler is fed to the turbine. There is partial expansion. The steam, let us assume that 1 kg of the steam enters the turbine. Now, from here, we extract M1 amount of steam after expansion at a pressure of P2. M1 amount of steam is extracted from the turbine after partial expansion at a pressure of P2, and the rest 1 minus M1 amount of steam is fed to the condenser, and in condenser there is phase change of the steam, that is, steam gets converted to water at pressure of P3, at constant pressure of P3. Now after phase change, the water is being pumped to H. This H is heat exchanger. Heat exchange takes place here. The 1 minus M amount of water, 1 minus M1 amount of water that is coming to heat exchanger, and M1 amount of steam, this M1 amount of steam and 1 minus M1 amount of water is fed to the exchanger. Now, the M1 amount of steam will give off its heat to the liquid that is feed water. Now, the steam will get converted into water after giving its heat to the feed water. Now, the steam that comes out of the heat exchanger is saturated liquid. So, the saturated liquid is now again pumped back to the boiler. The steam that loses its heat gives off its heat to the water. So, the water coming out of the heat exchanger has certain amount of heat. So, we will be supplying less amount of heat now because the water has certain amount of heat. I will be explaining this diagram through TS diagram. Again, we will be taking ordinate as T and abscissa as S. This is the dome for the TS diagram. Now, let us consider this point as 1, inlet to the turbine. This point is 2, that is outlet of the turbine at a pressure of P2 for mass M1. This is point 3, that is exhaust for the 1 minus M1 amount of steam. This is point 4, this is outlet to the condenser and inlet to the pump. This is point 5, amount of water that is pumped to the heat exchanger. This is point 6, that is exhaust of the heat exchanger and inlet to the pump 2, and this is point 7, that is the water that is pumped back to boiler. Now, from 1 to 2 we have expansion of 1 kg of steam. So, let us consider point 1 here. 1 is at a constant pressure of P1 and temperature of T1, so 1 is there. 1 to 2 expansion of 1 kg of steam. So, this is expansion of 1 kg of steam. Now, you can see that M1 mass of steam is extracted. So, from 2 to 3 we have expansion of 1 minus M1 kg of steam. So, 2 to 3 expansion of 1 minus M1 kg of steam. 2 is at a constant pressure of P2, and let us take the tab as P2, and 3 is at a pressure of P3, so this 3. Now, the M1 mass that is extracted is fed to the heat exchanger, and this gets converted into saturated liquid. So point 2 gets converted into saturated liquid, and this is the point 6. So the final output will be 6. Now the point 3, that is fed inlet to the condenser, and there is phase change at a constant pressure of P3 and temperature of P3. So this line will be horizontal because this is phase change line at a constant pressure of P3 and temperature of T3. Now phase change occurs at point 4. This is point 4, that is saturated liquid. From 4 to 5 we have pumping. So 4 to 5 is pumping, and next 5 to 6 is being fed to the heat exchanger. So it is fed directly to the heat exchanger at constant pressure of P2, sorry, this is P2, and this is isobaric line, this is P2. Now from 6 again, 6 to 7 we have pumping. So 6 to 7 we have pumping to a pressure of P1, that is initial pressure. So now the line will be like this. This is again, it is pumped to a constant pressure of P1. This is isobaric line. This is isobaric line of pressure P2. So it's again back pumped to the boiler. Now we'll be deriving the efficiency. I would also like to mention one more point, that is, this is M1. M1 mass is extracted. This is 1 kg. M1 mass is extracted, and this is left 1 minus M1 kg. M1 minus M1 kg will again move till here, till point 6, and at 6, that is at here, we have 1 kg. So M1 and 1 minus M1. So we have here 1 kg. So this is the TS diagram for the regenerative cycle. We'll be now deriving the efficiency through this diagram. As we know that efficiency is equal to net work by heat supplied, and net work is equal to work done by turbine minus work done by pump. So work done by turbine is equal to, from point 1 to 2 there is work done by turbine for 1 kg of steam, and from point 2 to 3 work done by turbine is for 1 minus m1 kg of steam. So work done by turbine is equal to 1 kg into H1 minus H2, H1 minus H2, plus from point 2 to 3 we have work done for 1 minus m1 kg of steam. So 1 minus m1, and we have H2 minus H3. This is the work done by turbine. Work done by turbine is along line 1 to 2 and 2 to 3. Now work done by pump, we have two pumps, that is pump 1 was here, and we have another pump, that is pump 2 here. So work done by turbine is equal to work done by pump 1 plus work done by pump 2, and pumping is along process 4 to 5 and 6 to 7. So along 4 to 5 we have work done by pump is equal to 1 minus m1. You can see this 1 minus m1 moves like this. So here we have 1 minus m1, H5 minus H4, plus another, that is work done by pump 2, that is this pump, is from 6 to 7. And here we have this 1 minus m1 moves like this, and m1 is moving like this. So we are left with 1 kg of steam from point 6 to 7. So we have plus 1 into H7 minus H6. This is the work done by pump. Now heat is supplied during this process 1 to 7, that is heat supplied is equal to, this is the heat supplied, because the area under TS diagram gives the heat supplied, and heat is supplied for 1 kg of steam, that is for overall cycle. So heat supplied is equal to 1 into H1 minus H7. Now this is the heat supplied. So efficiency is equal to net work by heat supplied. That is, net work is equal to work done by turbine minus work done by pump by heat supplied. From these formula we have work done by turbine is equal to 1 into H1 minus H2 plus 1 minus M1 H2 minus H3. This is the work done by turbine and minus work done by pump. Work done by pump is equal to 1 minus M1 H5 minus H4 plus 1 into H7 minus H6 total divided by heat supplied, that is 1 into H1 minus H7. This is the formula of efficiency. Now let us understand a very important point through TS diagram. This is point 1, that is inlet to the turbine. This is point 2 at a pressure of P2. This is point 3. This is point 4, that is outlet to the condenser. This is point 5 after pumping. Point 6 and this is point 7. Now, the mean temperature of heat addition in this cycle, that is in reheat cycle, is during this process from 1 to 7. So, as we know that TDS is equal to DH minus VDP. During this process, that is 7 to 1, as it is isobaric process, so dP, that is change in pressure, is equal to 0. So TDS is equal to DH. So now PM1 with regeneration, this is for regeneration, is equal to DS. DS is equal to S1 minus S7. S1 minus S7, this S1 minus S7, that is DS is equal to S1 minus, this is DS for regeneration, is equal to DH, that is H1 minus H7. Now PM1, that is mean temperature of heat addition, is equal to H1 minus H7 by S1 minus S7. This is for regeneration. Now, as we know that is without regeneration, that is like for Rankine and for reheat cycle, the heat is supplied from process 1 to 5. This is 5. That is 1. This is isobaric process. Now, for PM1, without, I will be writing a without, that is without regeneration, is equal to H1 minus H5 by S1 minus S5. This is for without regeneration. Because S1 minus S5, this entropy. This was a lecture on regenerative cycle. Thank you.